everyone. Today we're going to be looking at section 2.5, lesson 1, which is on circumference of circles. For today's class, you're going to need a notebook, pencil, and a calculator. Our learning objective for today is that students will be able to calculate the circumference of circles. So let's get started. The first thing that we need to know is, what is a circle? Well, a circle is a round plane figure whose circumference, think about it as perimeter, is equal distance from the center. We can name a circle by using its center point. The circle to the right would be called circle A. So if you notice in our purple circle over to the right, we have a point that is clearly labeled right here, and it is labeled as point A. Because it is the center of our circle, it's directly in the middle of it, that is what we use to name our circle. Now we're going to talk about a couple of different parts that relate to our circle that are super important when we're trying to find the circumference. So the first one is the radius. It is a straight line from the center to the circumference of the circle. So an example of that would be if I started at the center of my circle here, I can draw a straight line out to the circumference, and this is our radius. So notice it is half of the width of the circle. So I'm going to actually put that, half width of circle. Okay, and I'm just going to copy this so we have this on the next slide. Okay, the second one is what's called the diameter. So it is a straight line passing from side to side through the center of the circle. The diameter is equal to 2 radiuses. So it's saying side to side, so from one edge to the other, and it has to pass through the center. So using that information, I could draw my line here. Notice my line is going directly through the center of our circle, that black dot. So this is our diameter. Keep in mind, a line like this right here, the pink line that I just drew, that is not a diameter. Notice it's not touching that black dot. So the line has to go from side to side through the center point. So our green line is our diameter. Keep in mind, we could have drawn the diameter going other directions. It could have been up and down. It could have been diagonally. I just drew it horizontally. And that is like the full width of the circle. Okay, what's also really important is that the diameter is equal to 2 radiuses. So we could actually write that as diameter is equal to 2 times our radius, right? We're multiplying that. So if I had, like, say, up here, our radius is 2. So say it's 2 meters. Let's add a unit. To find my diameter, I would have to multiply 2 by 2 to get 4. So the full diameter of that top circle would be 4. Notice we could do the opposite. If I said this was 4 meters down here, to find our radius, we would have to divide by 2. 4 divided by 2 gives me that original radius of 2. So let's do some practice with this. On here, it's parts of a circle. We want to find the radius and the diameter using the diagram. Looking at number 1, right, automatically, I know that we're given the radius. So I can label that. Our radius is 3.7 miles. And remember to always include your units. To find the diameter, well, I know that the radius is the diameter is 2 times the radius. So I'm going to do 2 times 3.7 to get our diameter. And when I type that into my calculator, I get 7.4. So our diameter is 7.4 miles. Looking at the second one here, my green circle, I now see that it's spanning the entire width of the circle. That means it's our diameter. So our diameter here is 14 centimeters. Now to find the radius, we have to do the opposite. So I need to do 14 centimeters divided by 2 to get 7 centimeters. Try the last one, see what you get for an answer. I'm gonna continue doing it. So for this one, it looks like we're given the diameter, and it is 13.2 inches. Again, to find my radius, I have to divide by 2. So I'm going to do 13.2 divided by 2. When I type that into my calculator, I get 6.6, and then it's inches. And there we go. That's how we can find our radius and diameter when we're given diagrams that have certain parts labeled. Next thing I want to talk to you about is circumference. The distance around a circle is called circumference. So very similar to what we were doing in 2-3 when we were finding the perimeter. Just keep in mind it's not as simple. We can't just add up the sides, right? The circle only has one continuous side, so we have to actually use other information to find it. The circumference is related to pi. For this class, we are always going to let pi equal to 3.14. Some calculators have a pi button, some don't. So for this instance, that's why we're always going to use 3.14 for pi. And then you're going to need to know these two formulas. Notice that they're slightly different. One involves the diameter and one of them involves the radius. So if we're given an example where we have the diameter, we're going to use this formula. This one's specifically for diameter. If we have a diagram where we're just given the radius, we're going to use this formula. Notice the difference between them. The one with diameter is just pi times diameter. The one with a radius is 2 times pi times r. If you remember, the radius or the diameter is 2 times the radius. So that's why we have to multiply the 2 in the second formula. We're trying to make that radius into the diameter. Let's do some practice with this. So we have to find the circumference of our two circles. Looking at number 4, I know I'm given the diameter. So we're going to use the formula area is equal to pi times diameter. We know that pi is 3.14, and in my circle, my diameter is 3.25. So I am going to multiply those. And I get 205.205. For this class, I'm going to ask that you guys round to the hundredths place. So when I round this, I'm going to get 205.21. So your hundredths place is that second decimal there, okay? That's what we're rounding to. And then because we're finding circumference, we have to use our units for this, which is kilometers. We do not square it. Remember, squaring is only for area. So we are finding circumference, so we're not squaring it. Looking at number 5, I notice that I'm given the diameter again. So I'm going to use that same formula. I'm going to have area is equal to pi times diameter. Our pi value is 3.14, and our diameter is 11. So I'm going to plug that in. And again, I'm going to do 3.14 times 11. I get 34.54. And then my units are in feet. So that is the distance around the circle. Think about it as like a wheel or a tire on a bike. Think of like, so we're trying to find in one rotation, how far can we go? Let's do two more. Notice in these last two, the diagrams are slightly different. We now have the radius instead of the diameter. So now we're going to use the formula. C is equal to 2 pi r. Well, I have 2 times, my pi value is 3.14, and now we have to plug in for the radius, and my radius is 4.2. And now we're just going to multiply across. 2 times 3.14 times 4.2 gives us, it's 26.376. So I'm going to actually write that. Now, as an example, right, we want to round to the 10th place, which is this place here. So to figure out how I'm going to round, I'm going to look at my decimal to the right of it. It is larger than 5, so I'm going to round up. So when I round up, I get 26.38, and then my units is centimeters. For the 7th one here, I'm going to use that same formula. So 2 pi r. We're going to have 2 times 3.14 times our radius, which is 17. Again, I'm going to type that in, 2 times 3.14 times 17, and I get the answer of 106.76. And then our units here are in yards. Okay, and there we go. That is it for today's lesson. If you have any questions, please reach out. Thanks. Bye, guys.